The class 9 taught you the three laws of motion, but JEE does not ask you to state them. It asks you to apply them. Two blocks on inclines, strings over pulleys, surfaces with friction, and there's one skill that unlocks every single one of those problems. That's the free body diagram. So master that and Newton's laws questions becomes almost mechanical. So let me show you. So we'll walk through the laws of motion in J level, and the main important topic in that is the free body diagram method. If you understand it properly, then I think every question of mechanics will become a cakewalk, and you will realize that how important it is. And in every question of mechanics, it's the first thing we do. Okay, so it's very important that everyone should understand the free body diagram before starting mechanics. Okay. And if you haven't seen my class 9 Newton's laws of videos for the basics, the link is in my description. So this one assumes you know the three laws and goes straight to applying them. So what is an FDB? FDB is basically a free body diagram. It's a sketch showing every force acting on an object and nothing else. Get this right and the maths writes itself. So there are four forces you will meet again and again. There might be more, but I think these are the most important ones, which you will see in most of the questions and in most of the real life examples. So the first one is the weight, which is the straight down, or we can say towards gravity. So if in a fictionary question there is a gravity in another direction, the weight will go in that direction. Okay, but we assume in regular cases that there will be gravity downwards, so the mg will be downwards, which is the weight. Normal. So normal is the perpendicular to the surface. So if the body's weight is downwards, it's applying force on the ground in the downward direction. So the ground will exert an equal and opposite force in the opposite direction, which we call as normal. Okay, and it has to be perpendicular to the surface. Tension, so there will be cases when we will have a string, and there will be examples on that case. So there you will see tensions. The tension will be along the string, and it will be away from the attached object. So let's say this block if this block was being attached to a string, so and there was no surface, so the block was hanging from the string, and the block was exerting a force on the string, right, of its weight, and the string will have a force of mg weight, right? So that's the tension on the string which is along the object. Okay, and the tension will be on this direction away from the object. Now friction will be along the surface. Friction is basically a force which opposes the motion. So if anyone is trying to pull this block with a force of F, the friction will try to resist that motion and it will be applied in this direction. So that's one of the most important forces which feel required in mechanics. So that's a FBD, or free body diagram of an object lying at rest. Sorry, that's a free body diagram of an object on a surface. This is the mg in the downward direction. This is normal from the ground on the block. The, there's a force. I'm assuming that there is a force on this block, and then there will be friction from the ground. So this is an FBD of a normal scenario. Okay. To solve such problems, we first need to identify the axis. We have to we have to bifurcate the forces in two perpendicular axes. So let's say in this direction, the easiest axis will be, since the forces are in vertical and horizontal, the easiest axis will be vertical and horizontal. Okay. I am not giving any names to axes. It's just two perpendicular axes, and then you need to solve the forces in these axes only. Okay. And while solving the forces in each axis, we apply Newton's laws of motion, which is the second law, separately in each directions. The net force in any direction equals the mass into acceleration in that direction. Okay. So basically, if let's say we are solving in this vertical direction, we'll see normal and mg. So the net force of, let's say if they are not equal, so the net force of mg minus normal, or normal minus mg, will be the mass into acceleration of this block in vertical direction, not in horizontal, because Normal, the component of normal in the horizontal will be what? This is perpendicular 90 degree, right? So if we take component of normal into horizontal direction, what will be the component? The component will be normal cos 90 degree, right? Cos 90 is 0. So the component of normal in horizontal direction is 0. So we don't have to take component of normal when we are calculating the forces in the horizontal direction. So that's why the forces along each axis are exclusive. So, and similarly, when we calculate the forces in the horizontal direction, we have forces as force and friction. So we'll take the net of it, let's say force minus friction, and that will give us the mass into acceleration. And if they are not zero, if the force minus friction is not zero, we'll have some acceleration. So that's how we solve most of the problems. We draw an FPD, we uh, find out the perpendicular axis, and then we solve the forces in those two directions. Okay. And these are the four forces which we'll meet again and again in most of the scenarios. Okay. So, so I've drawn axis here. This is the vertical axis and this is the horizontal axis. From the FBD of the block, I have just put the forces on the axis, which we talked about just now. And it's just to show. So in the upper direction there was normal. In the lower direction it was mg. In the right direction there was force, and in the left direction there was friction from the ground on the block. So if we have to solve the forces in each of the directions, in each of the axes, what we'll do first, now we know that uh, there is no acceleration. The block is at rest from the vertical direction. We know that the normal minus mg equal to 0 because the acceleration is 0. So normal has to be equal to mg. So we'll get n equal to mg because it's already balanced. Now let's say in the horizontal direction, we'll have to balance f and f, small f. So the net force will be capital F minus small f, which will be m into a. If the block is at rest, if the block is not moving, then the F, capital F equal to F has to be balanced. But if it's not balanced, then we'll have some acceleration. Let's say F, capital F minus small f is 5. So acceleration will be 5 upon m. Okay. So that's how we solve most of the problems. And that's the whole simple way of solving mechanics problems. Okay. That's the basic concept. Now we'll move to some examples. So the first example is that the two blocks on a frictionless table, 3 kg and 2 kg, touching each other. A force of 10 Newton pushes the 3 kg block. Find the acceleration and the contact force between them. Okay, so how we'll solve it? Let's first create the FPD. So let's look at the solution. Two blocks on a frictionless table. So this is a table. Now this is a table. First block is a 3 kg block and the next block is a 2 kg block. Okay, this is solution for A part. Uh, okay, so we have to find out the acceleration, right? And this is a frictionless table. So if you think about it, uh, 3 kg block is being pushed by a 10 Newton force, and then there is a 2 kg block. So if the 3 kg block moves, what will happen to the 2 kg block? It cannot stay at rest, right? If the 3 kg block is moving, then the 2 kg block also has to move, right? So let that so hold that thought. Now first create the FTP. Now we'll first create the FPD. That's the first step in every problem. So this is the FBD of a 3 kg block. The force is 10 Newton, and now 3 and 2 are touching each other. So there will be some contact force between them, perpendicular to the surface, perpendicular to the direction, perpendicular to this direction. So let's say that force is N1. So 3 kg block will a 3 kg block will see a force of N1 from the 2 kg block, and since there will be reaction to this force, 2 kg block will feel N1 from 3 block, right? 3 kg block. So now we know that if the 3 will move, the 2 also has to move, right? Because these two blocks will be in contact. It cannot happen that 3 is moving, the 2 is stopped. It cannot happen because 3 is moving in this right direction. So let's say if we assume 3 and 2 as a system, the N1 forces cancel out each other. What is the net force in the horizontal direction? The net force is the 10 Newton, which is the external force. So this is one thing to note, that the internal forces in a system cancels out each other, and the net acceleration of the system uh, um, is proportional to the force is proportional to the net force applied on the system. So the net force is 10 Newton, and the mass of the system will be 5, 3 plus 2, 5 kg. So what will be the acceleration? Force divided by mass. Force is 10, mass is 5. So 10 by 5 is 2 newtons. So 10 by 5 is 2 meter per second square. So the acceleration of both the blocks will be 2 meter per second square. Now we have to find the contact force between them. So we have the FBD. Now the acceleration of both the blocks is 2 meter per second square. So what we can do is, let's say if we apply a second law of motion on this block, what is the net force on this block? The net force is 10 minus n1, right? 10 minus n1, and which should be equal to mass into acceleration. Mass is 3 and acceleration is 2. It should be equal to 3 into 2, 6, right? So 10 minus n1 equal to 6. So n1 will be 10 minus 6, which is 4 Newton. So n1 has to be 4 Newton. Now, this is we did on a 3 kg block. Let's say we do it on a 2 kg block. The force applied on 2 kg block is n1. So n1 equals to mass 2 into acceleration. Acceleration is also 2. So 2 into 2 is 4. Oh wow. We have n1 equal to 4 Newton. So this proves that n1 on 3 and n1 on 2 kg block has to be equal, because they're equal in opposite forces on common surface. Okay. So this is how we solve the questions, and there will be multiple similar questions and you can solve it in a similar way. There might be difficult questions, but every question will have the same uh, way to solve it. First, FBD, solve the forces in two axes, and then balance the axis. Okay, it's the most important and the difficult part in every question will be to create FBD, and so try to focus on doing that step correctly, and the rest will become a cakewalk. Now, friction. So friction is where the most students lose marks. There are two kinds of frictions and the different matters. Uh, One is the static friction and one is the kinetic friction. Static friction is which adjusts to prevent the motion up to a maximum. Let's say block is at rest. I apply a force. It's not that the block will start moving from time zero, right? It will not move at time zero. It will move after some time when I try to increase the force. So the duration from time zero till the time it moves, there is a static friction which is being worked upon. So I start to pull the block. So there will be friction which will try to resist the motion of the block. That is a static friction. But it will reach to a certain point after which it will not be able to resist the motion of the block, and it will let go of the block. So that point is the maximum of the static friction, and that is mu Sn. So mu s is a static uh, s- coefficient of static friction into normal. Normal is the uh, weight of the object in this case. So if the force reaches mu s n, then this block will start moving, because the friction cannot go beyond that and the force is beyond that. So according to second law of motion, the forces will become unbalanced and there will be acceleration on the object. Okay. Now what is kinetic friction? So after the point when the block starts to move, the friction will change from static friction to the kinetic friction, and it will be a constant. So static friction was zero when there was no force, but when I start to apply force, the friction is increasing so that the block does not move. So the friction will always be equal to the capital F, right? It will start from zero and it will go till mu Sn. Okay. So let's say if the force is less than mu Sn, let's say it's 1 Newton, so the F will also be 1 Newton. Let's say if it's 2 Newton, the force will also become 2 Newton. But let's say if it goes beyond mu Sn, then the force will max out at mu Sn, and the block will start moving and the friction will convert to mu Kn, which is the kinetic friction while sliding. And that remains constant. If the force increases, the friction will remain constant at mu Kn. It only depends on n, and the n will always be mg in this case. The static friction is constant. Okay. So this is what I have written here. Small f, which is friction, grows with f until f equal to mu Sn, and then it slides with a constant friction of mu Kn. Now, now, the inclined plane is the most tested setup in JEE mechanics. The trick is to tilt your axis. So earlier we learned about vertical and horizontal axis, but let's say what if there is an inclined plane? So usually what we do is we tilt the axis. So this is a block lying on the slant tilted wedge. It is a slant surface. This is a block lying on it. So what will be the forces on this block? There is mg, right, towards down. Now there is normal perpendicular to the surface in this direction. And what will happen since the surface is in this theta direction, theta slope, uh, there will be a component of mg in this direction, right, which will be mg sine theta, and there will be a component in this direction also, which is mg cos theta. So now we have two components of mg in this direction and in this direction. So these two are perpendicular. So we can forget about mg. So we have mg sine theta and mg cos theta and normal in this direction. What will happen? The block, based on our common sense, the block will try to move in this direction only, right? It cannot move under inside the wedge. It has to move in this direction. So what will happen? There will be a force of friction which will try to resist this motion, right? So now what all forces we have in this case? We have normal, we have mg cos theta, we have mg sin theta, and we have friction. So this is one axis, and this can be one axis, right? So we have tilted axes which are perpendicular to each other. So instead of vertical and horizontal cases, in such cases you can have tilted axes. So what we'll do now? We'll try to balance the forces in each of the axis direction, right? So this is one direction. We have n upside, mg cos theta downside. So if the block can, so obviously the block cannot move inside the wedge, and if it's staying touching, if it is touching the wedge, there is no acceleration in this direction. So n equal to mg cos theta. In this direction, there is a force of friction, which will be, let's say if the block is not moving and there is mg sin theta in this direction, there will be static friction, which will be mu n. N is mg cos theta, so F will become mu mg cos theta. Now there is a force of mg sin theta. Let's say if mg sin theta becomes greater than friction, the block will start to move, and this F will change to kinetic friction. If the mg sin theta is less than F, then the block will stay at rest. Okay, so this is how we solve the problems when there are tilted axes. Okay, let's work out a problem. There's a 2 kg block sliding down a 3 kg incline. There's a 2 kg block sliding down a 30-degree incline with coefficient of friction equal to zero point 0.2. Find its acceleration. So, so we have, so we already have everything we need to solve this problem, right? The angle is theta is 30 degree, mass is 2 kg, g is 10, and mu is zero point 0.2. So what will be the normal on the block? The normal will be mg cos theta, right? M is 2, g is 10, and cos 30. So that, which is root 3 by 2, which becomes 17.3 Newton. Now, what will be the friction on this block? The friction would be mu n, right? So mu is zero point 0.2 and 17.3. So it becomes 3.46 Newton. Now, the what will be the force down the slope? The force is mg sine theta. So m is 2, g is 10, and sine 30 is 1 by 2. So it becomes 10 Newton, right? So what we see is that the force towards the down is more than friction. The friction is 3.46 Newton, and the mg sine theta is 10. So there has to be a motion towards the down direction. So 10. So the net force in this direction, according to the Newton's law of second motion, is mg sin theta is 10, F is 3.46. Net force is 10 minus 3.46. It should be equal to ma. The m is 2. So the acceleration can be 10 minus 3.46, which is 6.54, divided by m, which is 2. So it gives us 3.2 meter per second square in the downward direction. So the block is sliding with a 3.27 meter per second square acceleration down the slope. So this is how we solve the questions. It's a very basic question, but there will be more varieties of such questions, and you can solve it in the same manner. First, figure out the forces acting, then figure out the axis, and then just balance all the forces, and you're done. Okay. So, so the recap of this video is that first thing while solving any mechanics questions is that always start with FDB. Second is that the net force equal to ma along each axis. Okay, so you need to create axis, and then the net force on each axis will be mass into acceleration. The third thing to note is that when you have an incline, when you don't have a horizontal surface, when you have an incline, you need to tilt the axis along the incline and perpendicular to the incline. Split all the forces in those directions, and you will have everything you need to solve the question. Okay. Uh, and do these every time, and JEE mechanics stops being scary. Okay. So yeah, we'll meet in the next video with friction in detail, and that will cover most of the JEE concepts. And bye for now. Please like and subscribe such upcoming videos, and please drop your questions in comments. We'll meet in the next